Hi everyone. Well, it's time to discuss questions on coordinate geometry, so let's begin. The first question is about fill in the blanks. It is saying that in order to locate the position of a point in a plane, we require two perpendicular lines. Yes, that's true. We require two perpendicular lines. One of them is horizontal and the other is vertical. So we know we require a horizontal and a vertical line. Both are mutually perpendicular to each other. So the first blank is going to be horizontal. We require one horizontal line and we require one vertical line. The plane is called the Cartesian plane. Yes, and the lines, these horizontal and vertical lines meeting each other at 90 degrees because they are mutually perpendicular to each other, they are known as the coordinate axis. Coordinate axis. Among them, the horizontal line is called dash and the dash is known as the y-axis. The horizontal line is known as the x-axis and it is the vertical line which is known as the y-axis. Clear? The coordinate axis divides the entire plane into how many parts? Well, you have one line like this, one line like this. The entire plane is divided into 4 equal compartments known as quadrants. So, it divides it into 4 equal parts which are known as quadrants. After that, you have the point of intersection of the coordinate axis. So, the x-axis and y-axis intersect each other at origin. That point of intersection is called the origin. And what is it saying? The point of intersection of the x and the y-axis is called the origin. The distance of a point from y-axis is called what? The distance of the point from the x-axis is called what? Basically, if I may just revisit the concept of point in the Cartesian plane, what do? This is your plane, this is the x-axis, the vertical one is the y-axis. Both are meeting each other at origin, dividing my entire plane into 4 equal compartments, the first quadrant, second quadrant, third quadrant and the fourth quadrant. This we know. Now suppose this is my point, say P, how to determine its coordinates? That means what is x and what is y such that x comma y is the coordinate representation of point P. How to get x and how to get y. What is this x and what is this y? X is the x coordinate of point P. How do you get it? Y is the y coordinate of point P. How do you get it? From P, you drop a perpendicular onto the x-axis. Say this point is M. From P, you also drop a perpendicular onto the y-axis. Say this point is N. Right? First of all, please understand what is PM. PM is the length of the perpendicular drawn from the point onto the x-axis. When you have a line and a point and you draw a perpendicular from the point onto the line, then the length of that perpendicular is called the distance of the point from the line. Right now, point is P, line is the x-axis. I have drawn a perpendicular from P onto the line, therefore distance of this, the length of this perpendicular, length of the line segment joining P and M is known as the distance of the point P from the line x-axis. So this is distance of P from the x-axis. Right? Please try to understand whatever is PM, same is NO, this and this, they both are going to be the same. Right? So I have this is same as ON. Right? Also, what is PN? What is PN? From P, I have drawn a perpendicular on the line that is the y-axis. So, the length of the line segment joining P and N is called as the distance of point P from y-axis. So, the length of the line segment PN denoted by PN is the distance of point P from the y-axis. Clear? And you know that PN is same as OM. Coming back to our argument from the theory, we know that if I drop a perpendicular from P to M and I drop a perpendicular from P to N, and from origin I measure the distances till M and till N, that is going to give me the x and the y coordinate of point P. From O to M, this is going to be the x coordinate of the point, and from O to N is going to be the y coordinate of the point. But we all know OM is same as PN, so even this is x, and ON is same as PM, so even this is y. What is then x and what is then y? X is coming out to be equal to Pn, y is coming out to be equal to this On, right? So what is it that you're getting? Pm is same as y is same as On, Om is same as Pn is same as x. X coordinate of point P is coming out to be distance of the point from the y-axis, y coordinate of point P is coming out to be distance of the point P from the x-axis. So however far is point P from the y-axis, that is the x coordinate of the point, and however far is point from the x-axis, that gives you the y coordinate of the point. How far means you drop a perpendicular from that point onto these two axes and measure the length of that perpendicular, that will be the distance. So we have got the answer that the distance of a point from the y-axis is called its x coordinate, Another name is what for x coordinate of a point? Or abscissa. And the distance of the point from dash is called its y coordinate or ordinate. We know another name for y coordinate is ordinate, but distance from where? Distance of the point from the x-axis is called the y coordinate or the ordinate. Clear? Moving ahead, we have if x and y denote respectively the abscissa and ordinate of a point, then x comma y, this ordered pair, is called what? It's just called the coordinates of point P. It's called the coordinates of the point, right, of point P. The y coordinate of every point on x-axis is what? Now if a point is lying on the x-axis, say R is a point lying on the x-axis, what will be its y coordinate? Answer is its y coordinate will be 0. Why will it be 0? Y coordinate of any point is distance of that point from the x-axis. Y coordinate of point R is distance of point R from the x-axis. Because it itself is lying on the x-axis, its distance from the x-axis is 0. They are not at all far from each other. They are actually, the point is lying on the line. So it is just not far from the line. So the distance of the point from this x-axis is 0. That means the y coordinate of any point lying on the x-axis will be 0. The y coordinate of every point on the x-axis is 0, and therefore the coordinate of any point on the x-axis are of the form x comma 0. Some quantity in place of the x coordinate, but y coordinate certainly is going to be 0. Moving to the next question. It says that the x coordinate of every point on the y-axis, exact same argument. If suppose the point is lying somewhere on the y-axis, what will be its x coordinate? X coordinate of any point is distance of that point from the y-axis. Because the point itself is lying on the y-axis, the distance of this point from the y-axis is 0, right? And therefore its x coordinate will be 0. So the x coordinate of every point on the y-axis is 0, therefore they are of the form 0 comma some quantity, but x coordinate is certainly 0. What are the signs of coordinates of a point in various quadrants? This is the sign for x and this is the sign for the y coordinate of any point lying in the respective quadrants. In the first quadrant, x coordinate I know is positive, y coordinate is also positive. If a point is lying in which quadrant such that its x coordinate is negative, y coordinate positive. For x coordinate negative and y coordinate positive, the point should lie in the second quadrant. If the x coordinate is negative and y coordinate is also negative, that means the point is lying in the third quadrant. And if the point is lying in the fourth quadrant, then its x coordinate is positive, y coordinate is negative. We already know this. Next is, Plot the following points on the graph paper. Now of course in your paper, in your question paper, you would be provided the graph paper. Here right now we have to understand the concept of plotting points, right? What is that? Let's just draw the Cartesian plane. So that's the Cartesian plane. This is the origin, this is the y-axis, horizontal line is the x-axis. This is x dash, this is x, this is y, and this is y dash. So x o x dash is the x-axis, y o y dash is the y-axis, this is the origin. Fine. I have to plot the following points on the paper, -5, -7. Please look at this point, say this point is A. I have to plot point A whose x coordinate is negative, y coordinate is negative. The moment x coordinate is negative, I will focus upon the negative x-axis, which is ox dash, and y coordinate is negative, so I will be focusing upon the negative y-axis, which is oy dash. You all know if x o x dash is the x-axis, then ox axis is called the positive x-axis and ox dash is called the negative x-axis. If y o y dash is my y-axis, then oy is called the positive y-axis, oy dash is called the negative y-axis. Because x and y coordinates both are negative, my attention will be on the negative x-axis and negative y-axis, which gives me a signal that if ox dash and oy dash are involved, that means x dash o y dash quadrant is involved, and that means the point is going to lie in this quadrant, which is the third one. Definitely point A, that is -5, -7 will lie in the third quadrant, but exactly where? So as I told you, focus upon the negative x-axis and negative y-axis. Move, just look at the magnitude, don't look at the sign. Just don't look at the sign, look at the magnitude. Here magnitude is 5, here magnitude is 7. Ignore the minus sign. I have to move 5 units along the negative x-axis and 7 units along the negative y-axis. These two axes I have already finalized. So move 5 units along negative x-axis. 1, 2, 3, 4, 5. This is your -5. Move 7 units along negative y-axis. 5, 6, 7. Clear? Now draw a line which is parallel to x-axis passing through -7. Draw a line which is parallel to x-axis passing through -7 and draw a line parallel to y-axis passing through -5. The point where these two lines intersect is your point A, that is -5, -7. Clear? Let's move to the next one. This is 7, -4. Let's say this is point B. X coordinate positive, y coordinate negative. X coordinate positive means focus on the positive x-axis, y coordinate negative means focus on the negative y-axis. So I have which quadrant in picture? X, O, Y dash. That means my point B is going to lie definitely somewhere in the fourth quadrant. But where? So focus on the magnitude, 7 and 4. Move 7 units along positive x-axis and 4 units along negative y-axis. 7 units here, 1, 2, 3, 4, 5, 6 and 7. And 4 units along negative y-axis, 1, 2, 3, 4, this is -4. Now from here you will be drawing a line parallel to x-axis and from here you will be drawing a line parallel to y-axis. So somewhere here both the lines would be intersecting and this would be your point 7, -4. Right? Then you have -3, 2. So what did we have to plot? We have to plot C, that is -3, 2. -3 means negative x-axis and 2 here means positive y-axis. Negative x-axis, positive y-axis, quadrant is x dash O y. That means my point C is going to lie in the second quadrant. I just have to move 3 units in the negative x-axis direction and I have to cover 2 units, measure 2 units along the positive y-axis. So 3 units along the negative x-axis. This is -3, 2 units along positive y-axis. If I draw a line parallel to y-axis passing through -3, draw a line parallel to x-axis passing through 2. Here somewhere they will be meeting. This point is -3, 2, that is C. Here I have point D, that is -4, 0. -4 means negative x-axis. 0 as the y coordinate means that the point is lying on the x-axis itself. This is 0, y coordinate is 0 means that the distance of that point from the x-axis is 0, that means the point is lying on the x-axis. -4 is depicting that you just need to be along the negative x-axis. So point is lying somewhere on the negative x-axis for sure, right? It is not lying anywhere on the y-axis, it is lying on the negative x-axis. And where is it lying? You just need to move 4 units in the negative x-axis direction. So 1, 2, 3 and 4. This is -4. This point itself is -4, 0. That is point D. Clear? Next is 0, -4. Here x coordinate is 0 means the distance of that point from the y-axis is 0. That means the point is definitely lying somewhere on the y-axis. Now y-axis is divided into 2 parts, the positive y-axis, negative y-axis. Because y coordinate is negative, that means the point is lying somewhere on the negative y-axis. Where is it lying exactly? You just need to measure 4 units along the negative y-axis. 1, 2, 3, 4. This point is 0, -4. That's how you plot your points in the coordinate plane. Let's move to the next question. It says that see the figure and write the following. Let's see what figure is it talking about. We have to look at the figure and accordingly answer the query. The figure is this. Based upon this figure, we have to answer what are the coordinates of point B. Now see, how do you get the coordinates of point B? Coordinates of point B, drop a perpendicular from B onto the y-axis. This is the perpendicular drawn. Drop a perpendicular from B onto the x-axis. The distance of point B from the y-axis, say this point is K, then BK, the length of BK, distance of point B from the y-axis is the x-coordinate of point B. So, what did I just say? That the x-coordinate of point B is the distance of point B from the y-axis, that is the length of the segment BK. Right, and the y coordinate of point B is distance of point B from the x-axis. Say this point is S, then BS is the y coordinate of point B. What is BS? BS is same as KO. What is KO? This is 0, 1, 2, so KO is 2 units. So distance of point B from the x-axis is 2, that means its y coordinate is 2. And distance of point B from the y-axis, that is BK, is same as OS. OS is 1, 2, 3, 4, 5. 5 units along the negative x-axis, that means this is -5. Right? So -5, 2 are the coordinates of point B. Coordinates of point B are -5, 2. Is it understood? Once we have got through the coordinates of point B, let's move ahead and get other coordinates. So B we have got as -5, 2. Next I want coordinates of point C. C is here, exactly similar thing. From C, if I drop a perpendicular onto the x-axis, say this point is K and say this point is S. Then CK is going to be my y coordinate and similarly CS is going to be my x coordinate. What is CK? CK is same as OS, 1, 2, 3, 4, 5, 5 units along the negative y-axis. So -5 will be the y coordinate of C. What is CS? CS is same as OK. OK is how much? 0, 1, 2, 3, 4, 5, 5 units along the positive x-axis. So 5 is my x coordinate. 5, -5 is C. Moving to the next query of this question, it says that the point identified by the coordinates -3, -5. -3 is here, -5. -3, -5 means -3, means 3 units along negative x-axis, so you reach here, and 5 units along negative y-axis, so you reach here. Clear? What is the point identified by -3, -5? How do you get the point whose x coordinate is -3, y coordinate is -5? You draw a line parallel to y-axis passing through -3, draw a line parallel to x-axis passing through -5. Both these lines are going to intersect each other at this point, you can see that, and this point is your -3, -5. That means point E actually is -3, -5. Clear? So the point identified by this is E. The point identified by 2, -4. 2, -4 means 2 units along positive x-axis and 4 units along negative y-axis. So 2 units along positive x-axis you reach here, 4 units along negative y-axis you reach here. Now you draw a line parallel to y-axis passing through 2, draw a line parallel to x-axis passing through -4. Both these lines are going to intersect over here at point G, which will have coordinates as 2, -4. So it is point G which is having coordinates as 2, -4. Clear? The abscissa of point D. D is obtained when? D is obtained when basically there is a line parallel to y-axis passing through 6 and line parallel to x-axis passing through 2 are meeting. That means, what are the coordinates of this point? There is a line parallel to x-axis passing through 2, that is going to mean that 2 is my y coordinate, and there is a line parallel to y-axis passing through 6, so 6 will be the x coordinate. Or you can see it like that also, distance of point D from the x-axis is this much, which is same as this much, that is 2, so that will be the y coordinate, and distance of point D from the y-axis is this much, which is same as this much, which is 6 units, so that will be the x coordinate. So D is my 6, 2, so abscissa of D is 6, that means x coordinate of point D is 6. Next you have ordinate of point H. Ordinate of point H, this is H. Again you can see distance of H from the x-axis is same as this much, which is -3, basically 3 units along negative y-axis. So distance of the point from the x-axis gives you the y coordinate, and distance of the point from the y-axis gives you the x coordinate. What is the distance of point H from the y-axis? It is this much, which is same as this much, which is 5 units along negative x-axis, so it is -5. So -5, -3 are the coordinates of point H. Ordinate of H, that means the y coordinate of H. H is -3. Next is coordinates of point L. Coordinates of point L. Where is point L? This is point L. Point L first of all is lying on the y-axis, so its x coordinate is 0. What is its y coordinate? Y coordinate is distance of the point from the x-axis. From this point, when I drop a perpendicular at origin, it meets the x-axis. So what is the distance from L to O? OL is actually 1, 2, 3, 4, 5, 5 units along positive y-axis. So 0, 5 are coordinates of point L. And after that you have coordinates of point M. This is point M. Point M is lying on the x-axis, so its y coordinate is going to be 0. What will be its x coordinate? Distance of point M from the y-axis. From point M, when I will be dropping a perpendicular onto the y-axis, it will be meeting the y-axis at the origin. So what is the length of OM segment? OM segment has length 1, 2, 3 units, but 3 units along the negative x-axis. So -3, 0 are the coordinates of point M. -3, 0. And that completes our discussion over all the queries based upon this figure. That is, we are done. Let's move to the next question. In which quadrant or on which axis do each of these points lie? Verify your answer by locating them on the Cartesian plane. So I will again have to draw the Cartesian plane. This is x, O, x dash, y, O, y dash. Clear? First point is -2, 4. Now you should understand in which quadrant does it lie. So please try to get this fact very clear. The point can lie either in the first quadrant, second quadrant, third quadrant or fourth quadrant. Right? When will a point lie in the first quadrant, when in the second, when in the third, when in the fourth? If a point is lying in the first quadrant, that means it is lying on, this is x, O, this is x dash and this is y, O, y dash. If the point is lying somewhere on the x quadrant, that means it is lying in x, O, y quadrant. That means positive x-axis, positive y-axis is contributing. Positive x-axis means its x coordinate is going to be positive, y coordinate is going to be positive. If the point is lying somewhere in the second quadrant, this is the first quadrant. If the point is lying in the second quadrant is x dash O, y. The x coordinate is going to come from negative x-axis, y coordinate is going to come from positive y-axis. So its x coordinate will be negative, y coordinate will be positive. If the point is lying somewhere in the third quadrant, That means it's lying in x dash O y dash quadrant. So x coordinate will be coming from OX dash negative x axis and y coordinate from OY dash negative y axis. So x is also negative and the y coordinate is also negative. And if the point is lying somewhere in the fourth quadrant, that means it is lying in x O y dash quadrant. So the x coordinate is going to come from the positive x axis and y coordinate is going to come from the negative y axis. So x coordinate will be positive but y coordinate will be negative. Is it understood? Over here you can see in -2, 4 x coordinate is negative, y coordinate is positive. X coordinate is negative, y coordinate is positive. That means the point is lying in the second quadrant. So -2, 4 lies in the second quadrant. Next is 3, -1, x coordinate positive, y coordinate negative. X coordinate positive, y coordinate negative. That means point is lying in the fourth quadrant. So 3, -1 lies in the fourth quadrant. Then you have -1, 0. Because y coordinate is 0, that means this point is lying in the x axis. So -1, 0 lies on the x axis. And that too you can tell where. Because x coordinate is negative, it is actually lying on the negative x axis or OX dash. 1, 2, x coordinate positive, y coordinate positive. Both the coordinates are positive, that means the point is lying in the first quadrant. So 1, 2 point lies in the first quadrant. Okay. Then you have -3, -5, x coordinate negative, y coordinate negative. X coordinate negative, y coordinate negative, point is lying in the third quadrant. So you have -3, -5 belongs to third quadrant. Is it clear? Now that we have written this, we have to verify this by plotting these points on the plane. -2, 4, move 2 units along the negative x axis, 4 units along positive y axis. 2 units along negative x axis, 4 units along positive y axis. This point somewhere here would be -2, 4. Right? You know how to locate the points? Then you have 3, -1, move 3 units along positive x axis and 1 unit along negative y axis. 3 units along positive x axis and 1 unit along negative y axis. Right? So this point here is your 3, -1. Then you have -1, 0. The point is going to lie somewhere on the x axis where -1, 0 move 1 unit along the negative x axis. This is 1 unit along negative x axis. This is -1, 0. Next you have 1, 2. Move 1 unit along positive x axis and 2 units along positive y axis. This is 1 unit along positive x axis and 2 units along positive y axis. This point here is 1, 2. Then you have -3, -5, move 3 units along negative x axis. You reach here. Move 5 units along negative y axis. So 1, 2, 3, 4, 5. Somewhere here is your point -3, -5. Let's verify. -2, 4 lies in the second quadrant. Yes. 3, -1 lies in the fourth quadrant. Yes. -1, 0 lies on the x axis. Yes. 1, 2 lies in the first quadrant. Yes. And -3, -5 lies in the third quadrant. Yes. So it's verified. Moving to the next question, it says that plot these points given in the following table on the plane choosing suitable units of distance on the axis. So we again have to plot only, right? We again have to plot the points. Let's begin the plotting of these points in the plane. So how would you be plotting the points? Now over here, given in the form of table are points only. X coordinate is given, y coordinate is given. So -2, 8 is the point. -2, 8, where will you plot it? Move 2 units along negative x axis and 8 units along positive y axis. 2 units you move along negative x axis, 8 units you move along positive y axis. Right? And somewhere here would come out to be your point minus 2 comma 8. Say this is A. Then you have minus 1 comma 7. 1 unit along negative x-axis, 7 units along positive y-axis. So 1 unit along negative x-axis, 7 units along positive y-axis. This is 7. So you get this as minus 1 comma 7. Say this point is B. Then you have 0 comma minus 1.25. 0 comma minus 1.25 means the point has x coordinate 0. So it is lying somewhere on the y-axis, but because y coordinate is negative, that means it's lying on the negative y-axis. I just have to move 1.25 units along the negative y-axis. So this is 1 unit, 1.25 is somewhere here. So this is minus 1.25. This much units when I complete moving, I get the point 0 comma minus 1.25. This is C. Is it clear? After that you have 1 comma 3. 1 comma 3, where will you plot it? Move 1 unit along positive x-axis and 3 units along positive y-axis. You will get the point 1 comma 3. Say this is D, and then you have 3 comma minus 1, move 3 units along positive x-axis and 1 unit along negative y-axis. This gives you the point 3 comma minus 1. That's how you plot the points. After that you have the point of intersection of the coordinate axis is called what? The point where the coordinate axes intersect each other is called the origin. The abscissa and ordinates of the origin are what? 0 comma 0. That's very basic. Why? Because this point origin is at 0 distance from the x-axis and 0 distance from the y-axis. So its x and the y both coordinates are 0. Next we have the measure of the angle between the coordinate axis is what? Now obviously when these two lines I talk about, the x and the y axis or the coordinate axis, they are mutually perpendicular to each other. So obviously the angle of intersection is 90 degrees. So you have, because of perpendicularity, the angle is of 90 degrees. A point whose abscissa is 2 and ordinate is minus 5 is going to lie where? If the point is there whose abscissa is 2 and ordinate is minus 5, that means the coordinates of the point are 2 comma minus 5. So you have x coordinate is positive and you have y coordinate is negative. X coordinate positive means OX axis, y coordinate negative means OY dash. So the point is going to lie in the quadrant XOY dash, which is the 4th quadrant. So the point is going to lie in the 4th quadrant. Next I have points, these lie where? So here what is it trying to say? The points that are given to you both have y coordinate 0. Points which have y coordinate 0, that means their distance from the x-axis is 0, that means the points itself are lying on the x-axis. So the points are lying on the x-axis. This will lie on the positive x-axis because x coordinate is positive. So you cover 7 units. You walk or measure 7 units along positive x-axis. The point that you reach is 7 comma 0, and if you move 4 units along negative x-axis, the point where you reach is minus 4 comma 0. But both the points are on the x-axis. The ordinate of any point on the x-axis is what? If a point is lying on the x-axis, its distance from the x-axis is 0, so its y coordinate or the ordinate is 0. Next I have the abscissa of any point on the y-axis. If a point is lying on the y-axis, that means its distance from the y-axis is 0, that means its x coordinate or abscissa is 0. The abscissa of the point is positive in which quadrant? Let's move to our quadrant study. Abscissa means the x coordinate. If a point is lying in the first quadrant, x coordinate is positive. In the second quadrant, x coordinate of the point is negative. In the third quadrant, again it's negative. In the fourth quadrant, it is positive. So in which quadrants is x coordinate of the points positive? In the first quadrant, x coordinate is positive. In the fourth quadrant, x coordinate is positive. But if the point is lying in the second or the third, then its x coordinate is negative. So abscissa of a point is positive in the first and the fourth quadrant. Right? Next I have a point whose abscissa is minus 3 and ordinate is 2. A point whose abscissa is minus 3 and ordinate is 2 is going to lie where? Abscissa is minus 3, ordinate is 2, that means x coordinate is minus 3, y coordinate is 2, so the point has coordinates minus 3 comma 2. X coordinate you can see is negative, y coordinate is positive. So that means what all is contributing to get the point? Negative x-axis and positive y-axis. So the quadrant will be x dash O y, that is the second quadrant. So the point is going to lie in the second quadrant. Clear? 2 points having same abscissas but different ordinates lie where? Now try to understand this. 2 points having same abscissa but different ordinates. Get the situation clear. This is origin x dash O, x, y, O, y dash. I am saying 2 points having same abscissa but different ordinates. Suppose this is 1 and say this is 2. I draw a line parallel to y-axis passing through 2. Right. Okay. What is the coordinate of this point? If I drop a perpendicular from this point onto the x-axis, if I drop a perpendicular from this point onto the x-axis and from here I drop a perpendicular onto here, say this is -1, or I should say this is 1, this is 2, this is 3, this is 4, this is 5, then you can clearly say that this point is going to be 2, 2. Distance of this point from the x-axis is 2 units. Distance of the point from the y-axis is also 2 units, so 2, 2. Say I talk about this point will be 2, 3, this point will be 2, 4, this point will be 2, 5. You can clearly see all these points have same x coordinate but different y coordinates, or I should say they have the same abscissa but different ordinates. Ordinates are differing, abscissas are remaining the same. Why is that happening? Because all these points are lying on the line parallel to y-axis passing through that abscissa which is the same. So if there are 2 points whose abscissas are same and ordinates are different, that can only happen if those 2 points are lying on a line parallel to y-axis. And what is the value of that same abscissa? It is that point at which that parallel line is cutting the x-axis. Is it understood? If I draw a line parallel to the y-axis, say this is 3, this is 4, cutting the x-axis at 4, then any point you pick up on this line is going to have x coordinate as 4. And y coordinates are going to differ. So over here, say this is 1.5, so this will be 4, 1.5, this is 2.5, this will be 4, 2.5. This one is say 3.3, here it is say 4.2, and this is say 5 itself, so 4, 5. So you can see that points have same x coordinate but different y coordinates only when they are lying on a line parallel to y-axis. So 2 points having same abscissa but different ordinates lie on a line parallel to y-axis. Next question says the perpendicular distance of the point from the x-axis. You know that the perpendicular distance of a point from the x-axis is equal to its y coordinate. Y coordinate of the point is 3, so this distance is 3. The perpendicular distance of the same point from the y-axis is going to give you its x coordinate, which is 4, so your answer is 4, and that brings me to the end of the discussion over the questions. Please revise them very, very nicely. All the concepts have been covered in here. That's it from my side. Take care. Thank you.